want us to do is they want us to show, I'm just going to move that up a little bit. They want us to show that A is -1 and B is 6. Now, we've done this together, all right? What does this fall under? Like, what heading is this? What are they asking us to do? Hello, Tiboho. What is this that they're asking us to do here, Matrix? We did it last week. Yes, exactly, Aisha. Exactly. They're asking us to determine the equation of the graph, but they're asking it to us in a very clever way because they're giving us the answers so that people that can't do this can still continue with the rest of the questions, right? Now, in maths, we also like to say to you guys, show that, because what we want you to do is we want you to prove something is true. When you do a show that question, and it doesn't matter whether you're doing a show that question in financial maths, whether you are doing it in analytical geometry, Euclidean geometry, trig, cubic functions, whatever. When the question says show that, you are not allowed to sub in what they've given you. Okay, you have to calculate those values like you didn't know that that's what they were. Okay, and arrive at those answers. Okay, so essentially you are ignoring those answers and you are working with this question and you are getting those answers all by yourself. Okay, so now since there is an A and a B, we say to ourselves, well, we have to solve simultaneously, right? Okay, and if we solve simultaneously, we need two equations. Right, now I showed you this last week, or not last week, I showed you this on Tuesday. All right, so I'm not going to say any more than that because I want to give you guys an opportunity to see if you can do this. Okay, so I've given you lots of hints. I want you to just try and see if you can do 10.1 for now. Okay, and if you think that you've done it, then say that you're done, and then we'll just see where everybody is, and then we can jump in and I can do it with you. Okay, all right, off you go. Are you guys managing? Okay, Mako's done. Good job, Mako. If you want to, Mako, you can carry on with the second question. There's no need to wait. I will do this with everybody though. Keep going, guys. I'm just going to wait another couple of minutes and see how everybody is then. Please, when you're done, put done into the chat and then we can go on and mark it and talk about it. Okay, good job, Kolofelo. So I'm just checking in again. Is 10.1 going okay, Matrix? Are we able to do this? Is there anybody having a problem? Can I start to work through it now? I just want to get a feel for where you're at. Okay, a little bit of help. Thelma says she's done. Not sure. Okay, all right. So let's just go through it. Because obviously this is something that Sure, Tisha, this is something that I want you to be able to do. Okay, no problem at all. Okay, so let's just move, whoopsie daisy, sorry. Finger trouble. Okay, so you know what I'm going to do? I'm going to delete that, move this over, put that over there. And then for now, I'm just going to write up here where we've got a little bit of room. Tibocho says, I get the value of A as -8. I don't know what went wrong. Okay, so Tibocho, you probably, maybe you made a mistake with an exponent or you multiplied something, but this is how we should do it, okay? So we need to work with this point over here. Okay, working with the origin doesn't help us because if we sub in 0, we're just going to get 0 as an answer, and then it's going to be 0 on the left and 0 on the right, and it's not going to help us at all. So we've got to work with this point that's 4 and 32. Okay, so we know that at B, two things. Okay, it's a turning point, so the gradient is 0 at B. The first derivative is equal to 0 at B. Okay, and it is a point that we can plug into the equation. So we can treat it like a normal xy. Okay, so that's the first thing that I'm going to do. So I'm going to sub in b into h of x. So in other words, 32, which is y, is equal to a, x is going to be equal to 4, which I need to cube, plus b, x is equal to 4, which I need to square. So this gives me my first equation by subbing in the point. I'm just going to simplify a little bit. So 32 is equal to 64a plus 16b. And I'm just going to leave it like that for now. I know it can be simplified, but I'm just going to leave it like that for now, and then I'm going to see where I'm going to go. The second equation I'm going to make is by taking the first derivative and subbing in 4. Okay, because the gradient at x equals 4 is 0. Do you want me to say that again? The gradient at x equals 4 is 0. Okay, so first derivative, h prime x is equal to 3ax squared plus 2bx. Okay, that's the first derivative. Okay, so now I need to sub in 0 because the turning point, the gradient of the turning point is 0. And this happens, matrix, when x is equal to 4. Okay, and now I'm getting my second equation. Right, so this is going to give me 48a, and that's going to give me 8b. Okay, and here is equation number 2. And now I need to solve these two simultaneously. How you want to go about it from here is completely up to you. All right, we'll talk about that now. How was that? Did you know that that was what you needed to do? I know there are obviously some people that did. Do you remember now? How do you feel now? Okay, so Kanisile got there. Okay, Aisha. Tebogo, have you found out what went wrong yet? Maybe when we do the Chantal, you say you divided the 8. Absolutely. 100%. So Chantal, either you can work with equation number 1 or you can work with equation number 2. I quite agree with you. So if you divide through by 8 here, you're going to end up with 0 equals 6a plus b. So that means that b would be equal to -6, wouldn't it? And now you can take that and go and sub it in place of your b. All right. So let's take our 32, our first equation, is equal to 64a plus 16 times b, and b is -6a. All right, so now we've got 32 is equal to 64a, and 16 times 6 is going to give us 96. So this is -96a. All right, and 64 minus 96 leaves us with -32. Okay, so now we can see where the -a for 1 comes from. Does that make sense to everybody? Oh, you sub the 32 into the second derivative. Oh my goodness. Okay. Yeah, no, remember the second derivative is concavity. Okay, the first derivative is gradient. All right. Yeah, good, Chantel. Me too. That's what I did as well. Okay, are we feeling a little bit better about that? And of course, now that we know what A is, we can go back and we can work out what B is by subbing it in. Okay, so that means that B, let me just move this up a little bit. B is equal to -6 times -1, and that's where the 6 comes from. Okay, so again, can you see how I'm just emphasizing it one more time? I did not use the 6 or the -1 when I started. Okay, I made two equations from what I know. So subbing in the 0.32 and 4 into my equation, and then working with the first derivative. Okay, because the 0.4 and 32 is a turning point. So the gradient at that turning point is 0. Okay, and that's how I got started. Good stuff. Yes, B is positive. It is 6. Quite right, Chantal. -6 times -1. Perfect. Okay, so that's that. Where would we get our marks here, Matrix? Let me just show you very quickly. Let's pick red. Definitely a mark for subbing in. Definitely a mark for the derivative. They normally give you a mark for the two equations and a mark for solving simultaneously. And then I suppose, where would the other mark be? The mark for the equations. Yeah, I'm not 100% sure where they would have put the last mark here. I mean, that would have been the solving simultaneously mark. Normally, it's sort of like on this line over here. You know, they would give an accuracy there. They're obviously not going to give you the marks on the answers because you said... just hang on a second. Chantal. Perfect. 100%. Okay, no problem, Chantal. You can certainly do that as well. That's fine. Okay, good stuff. The coordinates at A. So I know somebody had already, pleasure. I know that somebody had already done that. So A represents an x-intercept. Okay, so for the x-intercept, we need to let y be equal to 0. Okay, so let's do that next. So letting y be equal to 0. So we've got, sorry, 10.2, 0 equals minus x cubed. Was it plus? Yes, plus 6x squared. So there has to be a mark on that line for making y equal to 0. If we divide it through by -1, not that we really need to do that, but anyway, just makes it easier for us to factorize. We're going to take out our highest common factor. And we end up with x equals 0 or x equals 6. So I'm sure there would be a mark here for factorizing. And then we're not going to choose that answer. We're going to choose this one. Okay, because at A, x is equal to 6. And they wanted the coordinates. So let's just write those down like that. Okay, everybody happy with that? So 3 marks there. Okay, now in 10.3.1, they want us to write down the values of x for which h is increasing. Okay, so what does the word increasing mean? The word increasing means, it certainly does, Aisha, going up. In a mathematical sense, the word increasing means the gradient is? The gradient is That's it. Okay, the gradient is positive. Lovely. All right, so they're asking us for the values of x where the gradient is positive. So where are we walking uphill? Where are we walking uphill? The gradient is positive. Colofelo says between 0 and 4. Colofelo, I love your answer. That is perfect. Okay, so it's here. Quite right, Colofelo. When x is a number that is bigger than 0, but smaller than 4. Good job. Okay, so because it's this part of the graph over here, I'll just highlight it for you guys in turquoise as well. From there to there, that's where we are walking uphill. Nice. Okay, for what values of x is the graph concave down? Okay, how are we going to do this? How are we going to work out the values of x for which the graph is concave down? Short to Tebogo, not a problem. Okay, Colofrelo is on fire tonight. Well done, that's good. Okay, so we could use the second derivative, but I mean, this is only out of 2 marks. So we know that, no, Chantal, we don't even need to differentiate. So, yeah, we can use the midpoint, exactly, the midpoint formula. Okay, because we know that our point of inflection is midway between our turning points. So quite right. So our x coordinate at our point of inflection is going to be 0 plus 4. We're using midpoint formula, and that gives us 2. Okay, so the graph is going to be concave down. Quite right, Colofelo, when x is greater than 2. So from this point onwards, your graph is now concave down. Okay, good job. Well done. Thanks, Neliswa. Tebogo, if you still have issues, then I'm more than happy to go back over it again. Okay, so now matrix, we're going to look at question 10.4. For which values of k will minus x minus 1 cubed plus 6 x minus 1 squared minus k equals 0 have one negative and 2 distinct positive roots? Okay, so this is one of those kind of difficult, complex, problem-solving kind of questions that we often just look at and say, oh, no, we can't answer that. Right? But again, I want to expose you to these sorts of questions because I want you to see that what they're asking is not really that difficult if we first of all understand the question, and then obviously we know what it means. Okay, so how is what we see here related to what we already have? Can we find a connection? What's the connection between the two? Anybody see a connection here? Write this off in the meantime. I mean, does it look like anything that we've been working with? I mean, there's got to be some place we can start, right? You have A and B, you do. You do have A and B. Oh, look at that. Marco, nice. Nice, Marco. It looks like h of x shifted 1 unit to the right. Yes. Why, Marco? What was the giveaway? How do you know that it shifted 1 unit to the right? What are you looking at? Exactly. Okay, the x minus 1. Okay, the k, Chantal, is something else. All right, so what I'm going to do is this. I'm going to write in 10.4, come pen, I'm going to write minus x minus 1 cubed plus 6 x minus 1 squared. And now I'm going to take this k over to the other side. Okay. What I can see here is exactly as Michael has said, all right? In here, this is my original equation, except now, instead of me having just an x and it being minus x cubed plus 6x squared, now I've got x minus 1, and again, x minus 1. So when we add and subtract inside our bracket like this is exactly as it's an indication to you that some kind of horizontal translation has taken place. Okay, and in this case, because it's x minus 1, that's why Mako is saying it has shifted 1 place to the right. Okay, so because of the minus 1 inside the brackets, it has shifted 1 place to the right-hand side. So essentially what we've done is we've taken this graph and we've shifted it 1 unit to the right. Okay, so every single point on the graph goes 1 over to the right. Okay, if it goes over 1 unit to the right, what changes? So will this change? What's the new turning point at the new B going to be? Is it still going to be, yeah, there we go, 100% Chantal. So our new B, let's call it B prime, okay, is now going to be the point 5 and 32, isn't it? Good stuff. So it didn't move up or down, it just moved to the right-hand side, okay? What was the origin? So this was originally 0 and 0, right? What's our new origin? Well, our new coordinate going to be? It's going to be 1 and 0. Okay, so that would have moved over as well, right? Not that that really matters, but there we go. So the graph has shifted 1 unit to the right-hand side. So now, because it's shifted 1 unit to the right, come now. All right, it's going to look, whoopsie, something like that, because it's shifted 1 unit to the right. Sorry, this is very badly drawn. Now, what they've said to us here is we want to have 1 negative root and 2 distinct positive roots. So when we compare, just get rid of that. When we compare this to k, what does k mean in this case? What does this k represent? It's not a y-intercept. It's a constant, quite right. So it's the line y equals, not a shift up or down, okay? It's a horizontal line. Y equals k, it's a horizontal line. So what's taken place here is that they have shifted the graph 1 unit to the right, And now they are doing a simultaneous solution between that graph that's been shifted 1 unit to the right and a straight line. Does that make sense to you? Okay, so the graph has been shifted 1 unit to the right-hand side. Okay, so it now does something, I'm just going to try and draw it a little bit better. It now does something like this because it's moved 1 unit to the right. And now there is a horizontal line, the line y equals k, right? So now we have got a horizontal line that can move. Now let me just draw the horizontal line in a different color to try and make it pop out. There it is. I don't know if we can extend it. There we go. Let's make it a little bit longer. So there's my line, y equals k. It is a horizontal line. Now, the equation that I've been given, what they want is that they want there to be one negative root and two distinct positive roots. One negative root and two distinct positive roots. So that means that it needs to cut the graph in one place where it is negative, okay, where x is negative, and in another two places where it is going to be positive. So if I take my graph, can you see now here, I've got where it is right now, all right, I have got one root that is 0, a positive root, and another positive root. That's what I've got. Okay, so if I move it down, right, am I still going to have a root that's 0 and a root that's positive and a root that's positive? No, I'm going to have 3 positive roots. So moving it down is not the right way. I need to move it up. Okay, so remember here, it had a root that was 0 and 2 positive roots. Now that I move it over there, what does it have? Okay, it's got, look here, it's got what we're asked for. We've got a negative root, a positive root, and a second positive root. And it will continue to have that between where I've just drawn now, okay, and up to this point over here. Once it goes past there, all right, then there are no longer 2 positive roots and 1 negative root. It's going to be just 2 roots. Obviously, what happens here is that this graph continues going forever and ever and ever. So it continues to go up in that direction. So if I move this line, why has the line changed color? So if I move this line up here, can you see I've still got a negative root and 2 positive roots. If I move it here, I've got a negative root and 2 positive roots. If I move it here, what have I got? 1 negative root, 1 positive root. Can you see that? Does that make sense to everybody? Okay, so that's what's nice about this. We can move things around. Okay, so 1 negative root. So it can't go past the turning point. All right, so now I've got to figure out, where does it start having a negative root? Well, it'll start having a negative root once we move it from the point where it touches the y intercept, once we move that up. Okay, so anywhere between where it is right now and here. Does that make sense to everybody? Okay, not here, not there, but between the two. Okay, so somewhere in between these two. Okay, there's going to be a place where the straight line, the horizontal line, cuts the graph in 2 positive places and 1 negative place. Can everybody see that? Now, we know what the y coordinate at this point is. We know that it's 32. Okay, so going back here, all right, remember we know that it's 32. What we don't know is what the value of y is over here. But what we do know is that x is equal to 0 at this point, don't we? So what we can do is, in order to get the y coordinate at the x-intercept, at the y-intercept, because this graph has now been shifted 1 unit to the right, so its y-intercept is now different, we can sub 0 in. Okay, so I'm going to sub in 0 minus 0 minus 1 cubed plus 6, 0 minus 1 squared, and that's going to allow me to work out the y-intercept. Okay, and this is going to give me -1, +1, and then here it's going to be plus 6 times +1, so that's going to give me an answer of 7. Yes, Chantal, good. Marco, you're almost right. Almost right. So K has to be between 7 and 32, Marco. Okay, so when K is a number that's bigger than 7, but smaller than 32, the straight line will cut the cubic in a place where it's positive, 2 places where it's positive, and 1 place where it is negative. Okay, does that make sense to everyone? Yes, that's indeed right, Chantal. Good job. How does that feel, everybody? Okay. Yes, so Chantal, you'd have to write x is an element of, and then round bracket 7, semicolon 32 round bracket, and that would be another way for you to write it. Sorry, not x, k. Sorry, so you could also write it like this. K is an element, that's 32, and then a round bracket, that's fine. Okay, so I hope the reason why we substituted 0 is because we want to work out, remember we need the coordinates at this point, which we know is not 0, it was 5 and 32. So we need the coordinates at this point over here, which was 0 and 7. So we worked out that it was 7 when x was equal to 0, because this point where it cuts the y-axis, that is now the point where x is equal to 0, isn't it? So if the line is above that point, there's now going to be a negative root and 2 positive roots. Okay, so once I lift it up, can you see I've got a negative root and 2 positive roots? Okay, so between that y value at the y-intercept and the y value at the turning point, the straight line will cut the cubic function in 3 places, 1 of them negative, and 2 places where x is positive. Okay. All right, so we've only got 15 minutes left, and we've also got to leave time for you guys to do the quiz. So I just want to jump into the next question. So this is a very sort of typical sort of question. This is from 2019. The matrics that year wrote a seriously tough paper. So I just want to show you that question. Look at this. They were given f of x equals 3x cubed. That was it. And the first thing that they were asked to do was to solve for f of x equals f prime x. Okay, so what would we do here?
We will first have to get the first derivative.
100%. So what would the first derivative be? Can you see there? It would be 9x squared. Okay, so we would let 3x cubed equal 9x squared. And then again, we're going to get it into standard form. We can divide through by 3. We can take out the x squared. Oh, yes, x squared. And two solutions. So either where x is equal to 0 or where x is equal to 3. Okay, so the graph of this cubic function, okay, we know that it has an x-intercept and a turning point at 0, and then another x-intercept at 3. Okay, that's what the graph looks like. And we know that, again, it's going to be concave down and then concave up. In 9.2, the graphs f prime, and f double prime all pass through the points 0 and 0. In 9.2.1, for which of the graphs will 0 and 0 be a stationary point? What does the graph of f prime represent? It is the graph of the first derivative. Okay, so in other words, it's going to be, in this case, it's going to be a parabola. Okay, the graph of y equals f prime prime x is going to be the graph of the second derivative. And it's going to be a straight line. Okay, so in the form y equals mx plus c. Right, do straight lines have stationary points? Certainly not. Okay, so for which of the graphs will 0 and 0 be a stationary point? That will have to be for f and f prime only. Okay, because straight lines do not have stationary points. Explain the difference, if any, in the stationary points referred to in question 9.2.1. Look how different these questions are. Okay, we've never seen anything like that in a final paper up until this point. And there it is. Explain the difference, if any, in the stationary points referred to. Okay, so how would the stationary points be different in f and f prime? Are they the same? Are they different? I mean, if we started with a parabola, okay, so the graph of y equals f prime x, what does that stationary point represent? Exactly. Cool, Tanya, quite right. Absolutely. It's the turning point. Okay, so in here, okay, it is the turning point. So it's the turning point of the parabola. Okay. In the cubic function, what does it represent? The station point is also a turning point, isn't it? Okay, so it's also going to be a turning point. All right, so in y equals f, it's also a turning point. Okay. All right. See how different this is. So such weird questions. 9.3, determine the vertical distance between the graphs of f prime and f double prime at x equals 1. All right, so now if we want to determine the vertical distance of a line, okay, remember the vertical distance of a line. Let me just draw a vertical line here for you. A vertical line. There's a vertical line. All right, so if I want to know the difference between, let's say this over here is point F and that over there is point G. Okay, so if I want to know the length of FG, right, I will take the y at F and minus the y at G. Okay, so it's the same story here. Right, if I want to know the length of the vertical line, I need to take the f of 1, f prime, and I need to subtract f prime prime, okay, at the place where x is equal to 1. All right, so what is, we know what f prime is, it's 9x squared, okay, so this is 9x squared. We need to work out what f prime prime is. So f prime prime, we're going to derive the second derivative, so that's going to be 18x. Is everybody following that? Okay, so deriving the first derivative, that gives us 18x. Yeah, top minus bottom, quite right. So this is going to be 18x, and then we need to sub in the 1. Well, that doesn't make sense. Okay, maybe what we should have done here is this, because we can't end up with a negative distance. Okay, so let's do it the other way around. Okay, so here it's going to be, 18x minus 9x squared minus 9 times 1 squared. So it's going to be 9 units long. Okay, and that's going to be the difference between those two at that point. Okay, and now we can go on to, is everybody happy? Is it making sense to everyone? Are we good? Good stuff. Now, the last question is an inequality. All right, so for which values of x is f of x minus f prime x smaller than 0? Okay, so what I'm going to do here, I think just to make things easier for all of us, is I'm just going to rub that out. And I'll just write here, because if you do want to come back and watch these videos again, you've obviously got all this information anyway. So I'm not rubbing off anything we don't have. Okie dokes. All right, so let's do that. So f of x, remember, was 3x cubed minus f prime x is 9x squared, smaller than 0. Please, can you see 9.3? There it, yes, this is 9.3 over here, Chantel. Okay, this one here. Okay, cool. I'm going to go up again. Now, again, when we work with inequalities, we have to factorize. So if I take out 3x squared as my highest common factor, I'm going to be left with x minus 3 is smaller than 0. Okay, now I have a quantity multiplied by another quantity to give me a negative. All right, so something, which is going to be 3x squared times something else, gives me an answer that is a negative. Is it possible for 3x squared to be negative? Can 3x squared ever be smaller than 0? Okay, so it can't be, all right, because anything that's squared has got to be positive. And then if you take something that's positive and you times it by a positive number, it's going to be positive. So what we would say here is that we would say that 3x squared is greater than 0 for all real values of x. Okay, so it will always be positive. Okay, it can never ever be negative. So if that quantity is always positive, we have to look where this is negative. Okay, so that means that we need to consider those values of x where x minus 3 is smaller than 0. Okay, so that will be where x is smaller than 3. Okay, so I just solved my linear inequality. All right. Everybody happy with that? Sorry, and that was question 9.4. Sorry, very naughty. I don't write the numbers down. There we go. So that's 9.4.